Hi everyone, we're going to go ahead and get started. My name is Alexandre Ortiz and I'll be your host for today's webinar. I would like to thank you all for joining us today for this interesting session. During today's webinar, Simon Coulté and François Leclerc, both product manager at Creaform, will present you how Scott Sports and Koenigsegg use our technologies to maximize their product development process. But before I turn it over to Simon and François, I would like to mention a couple of things. First, we will be recording this session and make it available on Creaform website a few days after the presentation. A second thing you must know is that we'll take some time to answer questions you might have. So if you look at your GoToWebinar window, there is a question panel. We encourage you to ask us any question in that section, and we'll do our best to answer them at the end of the presentation. So thank you all and enjoy the webinar. Simon and François, the audience is all yours.
Thank you, Alexandra, and good afternoon, everyone. My name is François Leclerc, and I work here at Creaform as a product manager. I'm also a marketing enthusiast. What I mean by that is I'm a big fan of commercials, of publicity, as well as well-put campaigns.
So, hello everyone, I'm Simon Coté, and I'm very happy to be here with you for this great webinar. So I'm also product manager at Creaform. So beside Creaform and my family, I'm a winter sports fanatic. So contrary to normal people, I become really excited like a kid when it's cold and snowing outside. And you will see, I will detail a little bit more later in the presentation.
All right, thanks, Simon. So let's get started. I got to be honest, this is probably the most exciting content I've had the chance to present during a webinar. And so today we're going to talk about extreme skiing as well as supercars. Moreover, we're going to talk about product development for these two industries through the fascinating stories of two customers of ours, so Scott Sports and Koenigsegg. But before we do, there are a few things that we want to talk about. And the first one being fire, or actually the ability to control fire. That really was the first innovation of mankind, or at least possibly the oldest one ever documented. And then came the printing press, the telephone, and more recently, the internet. Now, those were all major innovations that changed the face of the earth and led us to where we are today. And these innovations, we actually owe them to our ability to think. Now, with the fierce global competition that's going on out there, it's very hard to stay on top nowadays, especially for engineers and designers who are constantly faced with the immense pressure to come up with new products and innovate faster. Now, how can they deal with these mounting daily challenges? Well, welcome to Product Development 3.0. Now, what is that, and how does it work? Well, first of all, first things first, let me introduce you to the process. So let's say that you have an idea, more specifically an idea for a product. This is generally referred to as a concept. And so during the concept phase, it's the origin of a project. It's where everything starts from. It's usually, you know that you want to do something, you just don't know how you're going to do it. And so this is what you try to figure during the concept phase. Then afterwards, you move on to the design phase. Now in the design phase, your intention is to get as close as possible to your final product. This is where you consider the actual design, the manufacturing process, the cost, and everything. So now you know exactly what you want to build, and now you need to start manufacturing. So there you move on to the manufacturing phase. And there you'll start manufacturing your product, you start making it, and you'll start to scale your production. And finally, you move on to the servicing phase, where your intention will be to maintain the quality of your product until you're ready to disassemble and plan for the next cycle. And if things went according to plan, this whole cycle starts all over again. So, you get the iPhone 1, the iPhone 2, the iPhone 3, you get the idea. So this entire process is called the Product Lifecycle Management, or PLM. It's the process of managing the entire life cycle of a product from start to finish. Now, Product Development 3.0 is actually doing this, but with modern tools, modern methods. Moreover, additive manufacturing, as well as 3D scanning. Now, these two technologies, they've been around for quite a while now and are already being used in product development. But the innovation actually comes from using the two combined. That's 3.0. And that is what companies like Scott and Koenigsegg are doing today. So if you're here today, you're probably aware that Creaform makes 3D measuring technologies, including 3D scanners, but you might not be familiar with 3D scanning by itself. And so before going any further, we're going to take a look at what 3D scanning actually is. So 3D scanning is the action of creating a virtual model that can either be complete or partial using a physical object. It lets you basically take physical objects into computer design processes such as CAD. And here on screen, what you see on the left-hand side of the screen is the actual part. And here on the right-hand side is the virtual replica, or the 3D model. It's a very accurate and detailed replica that's fully compatible with modern computerized processes. So how does it work? Well, most, if not all, handheld 3D scanners are comprised of a light source. That projects a single light pattern that's usually fixed. So it could be a line, it could be several lines, it could also be about any pattern for as long as it's known. And so when the projected light hits the object, the shape of the object, this pattern is going to be distorted by the shape of the object, and the distortion is going to be observed by a camera and interpreted into 3D data. And so data will be gathered over time in the form of a point cloud. So these are, points in space, or it can also be directly triangulated as a mesh. And since there's not much that can be done with a point cloud directly, at least for the purpose of reverse engineering. Point clouds are generally going to be converted to a mesh or an STL file afterwards. So, scanning and printing, how do they interact together? Well, I once heard the comparison that 3D scanning and 3D printing are like washer and dryer. And really, I can't think of a better way to put it. And let me show you why. Let's say that you have a part, a real one, and you want to take it into a CAD process. So you start by scanning it using a 3D scanner, then proceed to what's called reverse engineering, which is the process of creating a CAD model out of scanned data. So you get it into a CAD process. And there, you're free to modify it, transform it, improve it if needed. And then you want to be absolutely certain that the product that you're about to manufacture is great. So you send it to a printer, and there you'll get a physical copy of your modified part. And then you can manually modify it if needed. You can try it, feel it, and you can also scan it again if needed, and so on. And so in this example, we started with the actual part, but you could actually start at any point in this cycle. So how does what I just told you apply to product lifecycle management? So again, we start at the concept phase where you have an idea. You know what you're actually going to build. And perhaps your plan is to build an accessory for something that already exists. So here in this example, a customer of ours is actually building side booms for tractors. So that's the whole assembly, and that's what they're actually building right here. And so they don't make the tractors, but they want to ensure that what they make will fit on the actual tractors. And so here's what they do. They scan the tractors, they bring it into CAD, and they use it as a start point for their design. Here's another possibility. Maybe this is how you work best, using your own hands. A lot of artists and designers out there, they prefer to work with clay. They still feel like it's the best way to get exactly what they have in mind. But unfortunately, there isn't much that you can do with a clay model, besides improving it. So if you're making a car or if you're designing a product, chances are you'll need to take it into CAD. And of course, the best way to do it is to use 3D scanning. Now, perhaps you've made what seems like the perfect design in CAD, but how do you go from a CAD file designed on a computer to the actual model? You know, it feels like taking a big risk to manufacture the molds directly. So that's an easy one. You can print it, you can feel it, you can even try it and see if adjustments are required. So you basically validate your design and then you manufacture it. And maybe the feel is not right. You know, maybe it doesn't feel perfect. So you could always, you know, go back to your computer, try to modify your model until it feels right. Or you could simply prototype your file, you know, file it here and there, put some putty here and there, you know, feel it until it feels right, until it feels perfect, and then scan it and bring it back into CAD. You might have a design that needs to be tested in a wind tunnel. So you might need to scale your model up or down. So you can scan it, you can also print it. Maybe you don't have access to wind tunnel, but you can still test your model virtually using finite element analysis. So you just have to scan your model and take it into your software. Now, if you're at the manufacturing stage, you know exactly what you want to build, but you start with nothing. And there you'll need setups and toolings. And the manufacturing of these components can create some important lead times. So you can use 3D printing to generate your first setups and save some precious time. There are also things that you didn't think about, you know, tiny details. Here in this example, BMW, they were looking for a way to position their model tags onto their cars and always align them at the same location. So what they did is they designed the tool, they printed it, and this saved them time and money and also helped them standardize their production. Also very important is quality control. You want to make sure that everything fits, and if it does not, you want to catch problems as early as possible and correct them right on spot. And so you always need to control things, you know, because your tooling are going to wear out. Your production may vary over time. You'll get parts from different suppliers. And so by using a 3D scan to compare a CAD model with the actual real model, that is what's going to provide you with the most information. And here on screen on the left-hand side, you see the actual 3D scan, and on the right-hand side, you see a color map, which is a representation of the deviation between the actual part and the CAD model. And finally, you got your production up and running, and so you start distributing. So you might need to supply your customers with some documentations on service manuals or something else, for instance. So you might need to provide them with a clear representation of certain components. There you can use 3D scan for that. Your toolings, they need to hold until the end of the production. So, you know, they might need to be replaced at some point. So you can inspect them with 3D scanning and might, you know, replace them with 3D printing if needed. And finally, when it's all over and done, some installations, especially the complex one, they're going to be complex to take apart. And so you can perform some detailed planning using 3D scanning for that matter. And so as you can see, there are implications of 3D scans and 3D printing at all steps of a PLM.
So thank you, Francois, for this very informative content. So now we'll explain how our customers, such as Scott, are using Creaform device to streamline their product development. So first of all, for the one that are not familiar with Scott, they are a leader in the development, manufacturing, and sales of high-end performance product for biking, winter sports, motorsports, and running. So before we go any further, I would like to give you a little overview of Scott's history. So it's always good to know the background of a company to better understand what they do and where they're going. So Scott was founded in 1958 by Ed Scott. So the company started when they developed the first ski pole made of aluminum. So back then the normal ski pole was made of bamboo or steel. and the aluminum pole have been adopted really quickly by all skier and the whole industry. So that was the beginning of Scott. So after this success, Scott started to produce other sports goods. So for example, in 1970, Scott started the motocross goggle market. So later on, they also had accessories specially made for the motocross rider. And in 1989, Scott introduced significant innovation in cycling with the aerodynamic handlebar. So I could continue like that, but this is just to give you an idea of the company mindset. So the vision of the company has always been the same. So it's innovation, technology, design. So as of today, Scott continue developing, innovating product for different sports industry. So the main project I want to share with you today is related to their skiing market. So as you know, Scott don't make only ski pole made out of aluminum in 2017. So Scott makes skis, helmet, goggle, and pretty much all you need if you want to do what you see here on the picture. And like I said at the beginning, I love winter sports. So I'm a big fan of Scott since my early age. So actually my second board was a Scott USA, as you can see on the picture. So that was probably about like 12 years ago, where, yeah, around like 2005. So I still have this board in my garage. I'm still riding it once in a while. But I can tell you that probably the board is still in better shape than the guys right now. But it's also proved that the quality of Scott product is also always on top. And as you can see also on the picture, the safety was probably not my priority at that time. So that's bringing me to the main topic of this presentation. So this year, Scott will introduce to the market a brand new helmet, so the Symbol 2. So this helmet brings skiing safety to the next level. And according to Scott, Creaform technology has been very handy during the development of this product. So this new helmet integrates multiple innovations that making it the safest and most ventilated helmet ever made. So having a good scan quality makes the development easier and faster for the designer. Without the scan data, it's very time consuming to make a hand model and bring it back to your CAD software. So using 3D scanner, it's easier, faster, and more accurate. So after printing the first prototype, designer can have it in their hand. They can play with it. They can get the feeling, the real feeling. So they can make manual change and bring those little change or adjustment directly back to your CAD and so on. So the handy scan makes CAD designer more confident for each iteration. And at the end, it reduces the number of iteration and also the reduce the time to market. So Scott has chosen the handy scan technology mainly because of the ease of use, portability, and versatility. So as you can see on this picture, the handy scan is perfect to capture different kind of material with high detail and also in restricted area. So with an handheld device, you can just aim the scanner to the area you need, and the scanner would just grab the surface, and you will get a 3D object, so the 3D shape of your object that you want to scan. As I just mentioned, the fact that the HandyScan technology is almost plug-and-play device and running on a normal laptop was really key for Scott. So even if they are using the scanner very often for different kind of project, scanning is still just one task out of many. So they need a device that is really simple to use. Turn on the laptop, plug the scanner, put a couple targets on the object, and they can scan pretty much everything. So there's no really learning curve. So it's also very handy since many people in the team are up and running with the device. So they don't have to dedicate a certain person for the scanning process. So everyone in the team are able to use it. So if they have a question or specific project they want to look at, if the scanner is available, they take it and they get the answer quickly. So as you know, sports accessories is very competitive market. So the look and feel of the product is very, very important. So at the end, everything goes down to the small details. So this makes the difference between a good and an amazing success on the market. So having a 3D scan data at every step on the product development makes you more confident and ensure that it will ensure a good final product according to the designer specification. So for your information, the Symbol 2 has been announced to the public last February at ISPO Munich. So this is the international main exhibition for sport industry. So, and you know what? Scott team won the gold winner for this new helmet. So I'm not saying that the HandyScan is the only reason why they won, but it certainly had something to do. So the Symbol 2 combine different technology and has established a new standard for safety. So it will be available for to the market for the next winter season.
And I just want to step in real quick here because I told you before I'm a big marketing enthusiast, and I got to be honest, I'm a big fan of Scott's marketing campaign called No Shortcuts. It really defines the Scott spirit of doing things the right way, for the right reasons. And well, here's how Scott Sports explains their campaign. It's how we see product design. It embodies the true beauty of sport. The greatest personal achievements aren't accidents. They're hard-earned and well-deserved. And I guess that's the reason why they chose the HandyScan 700. They took no shortcuts. They like it because it saves them time on product design, and it also makes them very confident about their measurement. It lets them scan about anything, anywhere, and it simply helps them make better products.
Thank you, Francois. And let me just go back to the other slide. So yes, Scott Sports use the HandyScan on other projects, so not just for the helmet. So they use it for all kind of projects, from bikes to body protection, as you can see on this picture. So having the technology in-house bring a lot of flexibility for them. They can scan it to their office, to the lab, and to the other facility as well. So it's also really a cost and time effective for them. So here's another example when working with a complex shape, what we call more freeform shape. A 3D scanner is crucial. So traditional is very time consuming and it will never achieve the same quality. So I mean, and even if challenging materials such as this black plastic on this goggle is not a problem with the scanner. So, and here is another picture of a Scott designer actually probably wearing his no shortcut shirt. For this time, they are using the scanner on boot liner. So again, just another example on what kind of application they're using the scanner. So Scott have been always an innovative company, so their history easily proved that, and by using technology like the HandyScan, it just helped them to continue developing, innovating product, bring them to the market faster, and also a way for them to stay competitive and even leave the competition behind. So I wish all the best for this great company. And now let's talk about the other very interesting case that we have. So it's not because they are using Creaform technology, but because of what they are doing. So Koenigsegg have been pioneers since the beginning, and they succeed in a very, very, very niche market. So it's the market of super sports car. So the type of car that all men, or probably even if all women would like to own one day, or even just drive for 1 hour will be enough for me. So let's start again with some fact about Koenigsegg to know more about them. So Koenigsegg was founded in 1994 in Sweden by Christian von Koenigsegg. So he was only 22 years old, and he had the intention of producing the world's greatest super sports car. So their first street legal car has been produced in 2002. So it took them about like 8 years. Over the years, they won multiple awards and recognition from the automotive industry. So, for example, in 2009, the Koenigsegg CCXR have been chosen by Forbes magazine to be one of the most beautiful car in history. So this is the one that you see on screen. In 2015, the Koenigsegg 121 actually got the Guinness World Record for the 0 to 200 kilometers per hour in less than 12 seconds. So since the beginning, this company has always pushed the limit to really accomplish the best. So here's the another view of the another CCXR. But for your information, Koenigsegg car has a full production car. But those cars are made for, it's not made for the mass market. So since they manufacture their car at a low volume, they face different kind of challenges on the production line. So they are mostly using Creaform devices to quickly identify those problems and solve them as soon as possible. So Koenigsegg develop and produce most of their parts. So the main system, the subsystem, and the component. So they prefer relying on their in-house constraint instead of relying on subcontractor that they don't control. So scanning technology help them to improve the quality of their individual part and ultimately the whole car as well. So they are using more and more the Creaform device during the design process to bring hand modeling inside their CAD software. Sometimes they also use the scan to get the information on specific area of the car and give that to the designer so he can actually design a part that will perfectly fit on this car. So Koenigsegg is driven by innovation and they use creative manufacturing process. So here on screen, you can see the first 3D print turbo in the world. So yes, they use a lot of 3D printing in their product development process as well as in their manufacturing process. So even if they are a small size company, Koenigsegg is globally recognized as a market leader in automotive industry. So just to give you an idea of the level of customization and the level of detail of a Koenigsegg car. So on screen are customized knobs they make. Yes, they pretty much produce everything by themselves. So Koenigsegg also use Creaform technology to set up their jig and fixture. Their efficiency has been improved since they're using our technologies because they have a better quality on the individual part prior to send them to the production. So here, just a couple of pictures here, just to show you that they use Creaform technology on different parts and also for different purposes. So this can be inside of the car, outside of the car, small part, and so on. And again, the ease of use, speed, accuracy, and good performance on the carbon fiber were the most important criteria when they choose to purchase Creaform technologies. Here's another application where Koenigsegg used their HandyScan, so to extract information on, I would say, confined space. And since they can achieve this kind of task easily, and all the other applications we talked before, Koenigsegg team can actually centralize their energy on other challenges. So Koenigsegg is always a company that impressed me, and I'm sure they will continue in the future.
All right, and finally, before we go for dessert, we want to tell you about this guy. Talking about skiing and supercars kind of reminded us of him. His name is Yoon Olsen, and he's a professional freestyle skier from Sweden who also happens to be a car fanatic. This guy is literally a rock star of free skiing. He's also famous for his taste in exotic cars and participating in racing events such as the Gumball 3000. Here is one of his latest creations, one that fits his oncoming lifestyle. And yes, ladies and gentlemen, that is a ski box on top of a Lamborghini. Where else could you put skis in a Lamborghini? Speaking of him being a car fanatic, he's had a few of his own over the years. Here's a sample of his collection, always with his signature ski box on top of the cars. And here is his Lamborghini from another angle. Now, as you can see, this is a true case of when professional skiing meets supercar. But it does not stop there for him. His simple Lamborghini was not enough for Mr. Olsen. And so that's when he got in touch with MLT, our reseller in Sweden. So they took his Lamborghini apart and scanned it entirely. Now his plan is to use these scans as a start point for a new build. He wishes to design a completely new and unique look for his Lamborghini in 3D. And, because a Lamborghini is not enough for Ms. Olsen. So the project is currently ongoing and waiting for the end results. You can follow his adventures on his blog. I got to be honest, he's an amazing photograph and also a great video artist, so he's a lot of fun to follow. Now what's next for Mr. Olsen? Could he be working on a project with Koenigsegg? We'll see, and this could probably be the topic of a future webinar. Who knows?